Hello everyone, I'm Ben, and today I'm going to be playing with these ThermoElectirc coolers, the TEC 12706 coolers. They are just these little ceramic blocks. You give them some power, about 12 to, I'm going to go to like 14 volts, roughly, and the one side gets cold and the other side gets hot. These work by using electricity to move the heat from the cool side to the warm side. Unfortunately, they're about only 10% roughly efficient, so not very efficient things, but they're really easy to use and they can get quite cold. So I've got one here attached to a heatsink with some Kapton tape and thermal paste. I've got the heatsink on the hot side to keep it from getting too hot, and that way the cold side can get even colder. And I've just got a little fan on the heatsink, and I'm just going to set that on this roll of tape to keep it up off the desk. To power this, I have this pretty large power supply. Doesn't really matter what it is. Its outputs come to the panels back here, and I've got channel 1 and 2 connected together to give me just a little bit more current than one channel can give. It's not necessarily recommended that you connect channels in parallel, but it works well enough for this, and the fan is powered from 12 volts on channel 4. I also have this DC clamp ammeter here on one of the power lines to monitor the amount of power, since one of the artifacts of using the two channels in parallel is that the currents don't necessarily just add up. And additionally, I have a piece of Kapton tape on the top of the cooler so that I have a surface of known emissivity, so when I look at it with the thermal imaging camera, we'll actually know how cool it gets. Alright, now I have the cooler and I have adjusted the light slightly so you should be able to see that there are a few drops of water on the cooler. And I'm now going to turn on the power supply and let it start to cool the cooler down. So already the surface of the cooler is below freezing, and we should see pretty soon here this water will start to freeze, and there we go. It's already ice. So as we look in from the side of the cooler with the thermal imaging camera, we can see that the cooler itself is fairly cool and the heat sink is getting quite warm. Now do note that the heatsink does not show the correct temperature on the metal, but if we look here and we measure the pieces of Kapton tape, they should be fairly accurate. So we see our hot side is, our heatsink is up to almost 36 degrees Celsius. And now we can see that the temperature has gone up to about -10. That's probably because as the cooler works, it's dumping the 40 watts of heat that it's using, as well as the little bit of heat that it's moving into the heatsink. And as the temperature of the heatsink rises, the cooler just can't quite keep up. So, if I want to cool it down even more, then counterintuitively, the way to do that is to turn it off for a few minutes, let the heatsink cool down, and then I'll come back in a few minutes once the heatsink is down closer to ambient, and we will try again and see how cold it gets. Alright, now that the heatsink has had a chance to cool off a little bit, I'll turn the power on again, and we'll watch how cool it gets. And there we are at the -10 where we were before. And we're well past that now. And that seems like that's about where we've capped off. So if we have the top of the element at about -15, and this piece of Kapton tape on the heatsink fairly near the element is at about 37. So we'll call the backside of the element maybe 40 degrees C. It's hard to say for certain. That's giving us almost a 50C differential across the device. So we can see that the ThermoElectirc Cooler works, and the water on top of it is turned to ice. So that's a brief introduction to ThermoElectirc Coolers. Thanks for watching.